Hello everyone! Before we dive into iterables, let's talk about something you'll use awfully a lot in Python, the print function and conditional statements. Think of this as learning how to speak Python out loud. If Python were a person, print is basically its mouth. And trust me, you'll want to know how to make it say things clearly. Let's start with a chemistry-flavored example. Suppose we want to calculate the molecular mass of carbon dioxide. C equals 12.011, O equals 15.99, CO2 equals C plus 2 times O. Let's typecast with str and concatenate them and print. Print str of C plus within quotes, str of 2 times O plus equals within quotes, str of CO2. This prints 12.011 plus 31.98 equals 43.991. Notice no spaces. It's like atoms crammed together in a molecule. Functional, but not pretty. Now try mixing strings and variables. Print C, comma, plus, within quotes, comma, 2 times O, comma, equals, within quotes, comma, CO2. Python politely adds spaces for you. 12.011 plus 31.98 equals 43.991. Very convenient. It's like Python saying, "Don't worry, I've got your formatting covered." Now, let's print them on separate lines. Print C equals 12.011, print O equals 15.99, print CO2 equals C plus 2 times O. Each equation gets its own line, nice and neat, like writing in your lab notebook. But what if you want them on the same line? Enter the end parameter. Print C equals 12.011, comma, end equals, single quote, print O equals 15.99, comma, end equals, quote, print CO2 equals C plus 2 times O. Yikes! This prints C equals 12.011, O equals 15.99, CO2 equals C plus 2 times O. Everything squished together. Ugly! Let's fix it by adding separators. Print C equals 12.011, comma, end equals, quote, space quote, print O equals 15.99, comma, end equals, space quote, print CO2 equals C plus 2 times O. Now it prints C equals 12.011 space O equals 15.99 space CO2 equals C plus 2 times O. Much better. Spaces are the oxygen of readability. Without them, your code suffocates. Whew. Using commas. Print C equals 12.011, comma, end equals, quote, comma, quote. Print O equals 15.99, comma, end equals, quote, comma, quote. Print CO2 equals C plus 2 times O. This gives you C equals 12.011, comma, O equals 15.99, comma, CO2 equals C plus 2 times O. Add a space after the commas if you want it to look civilized. Using tabs and new lines. Print C equals 12.011, comma, end equals, quote, \t, quote, print O equals 15.99, comma, end equals, quote, \t, quote, print CO2 equals C plus 2 times O. Tabs give you C equals 12.011 tab O equals 15.99 tab CO2 equals C plus 2 times O. Perfect for lining things up like a chemistry table. How about using \n? Print C equals 12.011, comma, end equals, quote, \n, quote. Print O equals 15.99, comma, end equals, quote, \n, quote. Print CO2 equals C plus 2 times O. And, of course, \n gives you separate lines again. Classic! Canceling end effects. Print C equals 12.011, comma, end equals, quote, comma, space, quote. Print O equals 15.99, comma, end equals, quote, space, quote. Print CO2 equals C plus 2 times O. This prints C equals 12.011, comma, space, O equals 15.99, space, CO2 equals C plus 2 times O. The empty print acts like a reset button. Handy trick. Now, let's talk about formatted string literals, aka F-strings. This works for Python 3.6 plus. Think of them as Python's version of C, C++, printf, but cooler. Printf, quote, C equals curly brace capital C, comma, O equals curly brace capital O, comma, CO2 equals C plus 2 times O equals curly brace capital CO2, quote. This prints C equals 12.011, comma, O equals 15.99, comma, CO2 equals C plus 2 times O equals 43.991. Variables inside curly braces get replaced with their values. Magic! You can use uppercase F and single quotes too. My underscore F underscore string equals F, single quote, C equals curly brace capital C, comma, O equals curly brace capital O, comma, CO2 equals C plus 2 times O equals curly brace capital CO2, quote. Print my F string. Notice, just don't put a space between F and the quote, or Python will give you the silent treatment. Now take a look at C, C++ format specifiers. In C, C++, you'd write this: float mass equals 12.011. Printf, quote, atomic mass, colon, percent 0.2f, quote, comma, mass, bracket close. In Python, we use F-string format specifiers with a colon instead of percent. Print F, quote, mass of CO2 equals, curly bracket, CO2, colon, 0.2f, curly bracket close, quote, bracket close. This prints mass of CO2 equals 43.99. 2 decimal places, nice and tidy. Perfect for lab reports where precision matters. For the full list of format specifiers, check out the Python docs. Don't worry, they're less scary than MSDS sheets. Jing. Point https://docs.python.org/3/library/string.html#format So, that's it for now about various print methods in Python. Remember, formatting your output is like formatting your lab results. If it looks messy, nobody will trust it, even if the science is solid. Next, we'll tackle conditional statements. All right, folks. Now let's move on to how Python decides things. That's right. Today's star is the mighty if statement. Think of it as Python's brain. Without it, Python is just a parrot repeating numbers. With it, Python can actually make decisions, like you do every day. Picture this. You're coming home from school. On your way, you meet an attractive person. What do? Maybe go to the movies together. But what if you run into a villain? Maybe you run away. Or worse, get mugged. Or maybe nothing happens at all. You just arrive home uneventfully. Believe it or not, we can express all of this in Python using if statements. Case 1. Only the first event matters. If you meet an attractive person, go to the movies. Simple. If the condition is true, you go to the movies. If not, Python shrugs and does nothing. Case 2. 2 possible events. If you meet an attractive person, go to the movies. Elif, if you run into a villain, be mugged. Here, Python checks the first condition. If it's false, it checks the second. If that's true, well, sorry, you're mugged. Case 3. Even arriving home uneventfully matters. If you meet an attractive person, go to the movies. Elif, if you run into a villain, be mugged. Else, arrive home. Now we've covered all bases. If neither exciting nor terrifying things happen, you just arrive home. Python likes closure. If syntax and rules. In Python, the syntax looks like this. If condition, statements. Elif condition, statements. Else, statements. If is mandatory. Elif, short for else if, and else are optional. You can have multiple elif conditions. And don't forget, indentation matters. Python is picky about whitespace. Forget to indent, and Python will scold you with an error. Boolean logic in action. A condition is either true or false. If it's true, the block right under it runs. Then the whole if, elif, else block exits. Let's see this in chemistry terms. Let's abbreviate electronegativity as EN. ENH equals 2.1. ENC equals 2.5. If ENH minus ENC is greater than 0, print H has partial negative charge. Elif ENH minus ENC is less than 0, print H has partial positive charge. Else, print H has no partial charge. Print next please. When you run this, the console prints H has partial positive charge. Next please. Why? Because ENH minus ENC equals 2.1 minus 2.5 equals minus 0.4. That makes the second condition, ENH minus ENC less than 0, true. So Python executes that block. Then it moves on to the next statement outside the block. Print next please. Easy peasy. Operators. Now, let's talk about the operators you can use in conditions. First up, comparison operators. Equals equals tests equality. If A equals B, it's true. If not, false. Warning, never use a single equal sign for equality. That's assignment, not comparison. Also, don't use equals equals to compare floats. They're rarely exact. Not equal means not equal. Greater than means greater than. Less than means less than. Greater than or equal to means greater than or equal to. Less than or equal to means less than or equal to. Basically, Python is like a math teacher. It loves comparing things. Next, logical operators. These are the ones that make Python think like a philosopher. And. True only if both conditions are true. Or. True if at least one condition is true. Not flips the result. If something is false, not makes it true. Example, A equals 4. Not A greater than 5, true, because A greater than 5 is false. Bitwise operators exist, but we are not covering them here. Save that for another day when you're feeling brave. Let's apply this to chemistry. A substance is a strong acid if pKa less than or equal to 0.00. A weak acid if pKa is greater than 0.00 and less than 14.00. A base if pKa greater than 14.00. Let's test benzoic acid with pKa equals 4.20. pKa equals 4.20. If pKa less than or equal to 0.00, print strong acid. Elif pKa greater than 0.00 and pKa less than 14.00, print weak acid. Else, print base. This prints weak acid, which makes sense. Benzoic acid is indeed a weak acid. Chemistry and Python agree. Isn't that satisfying? So, there you have it. In this video, we covered Python's if statements, how they let your code make decisions. Combine this with the print tricks, and you've got the foundation for scientific computations. Python is like chemistry. It's all about conditions, reactions, and outcomes. Sometimes you get a movie date, sometimes you get mugged, and sometimes you just get home safely. Thanks for watching, and stay tuned for more Python plus chemistry adventures.